Welcome to this comprehensive tutorial on the Serpent Encryption algorithm. In today's video, we'll explore what Serpent is, its significance in the world of cryptography, and how to implement it in your Java applications. So, whether you are a beginner or an experienced developer, stick around for detailed explanations, coding examples, and best practices. Let's start with a brief overview of the Serpent algorithm. Serpent was designed in the late 1990s as a candidate for the Advanced Encryption Standard, AES. It is a block cipher that uses a key size of 128, 192, or 256 bits and operates on 128-bit blocks of data. Its creators aimed for high levels of security and efficiency, which makes it a strong choice for data protection. Why should you care about encryption algorithms like Serpent? With the increasing amount of data breaches and cyber threats, understanding how to implement strong encryption algorithms is crucial for protecting sensitive information, whether for personal use or enterprise-level solutions. Now, let's talk about some important concepts before diving into the code. Encryption algorithms can be classified as symmetric or asymmetric. Serpent is a symmetric key algorithm, which means the same key is used for both encryption and decryption. It's vital to keep this key secure, as anyone with access to the key can decrypt the data. Before we start coding, let's install the Java Cryptography extension, JCE, if it's not already available in your Java environment. Just make sure that you're using JDK version 8 or higher, as it comes with built-in cryptographic support. To implement the Serpent algorithm, we will need a library that provides Serpent encryption in Java. For this tutorial, we'll use the Bouncy Castle library, which supports various encryption algorithms, including Serpent. Let's quickly show you how to add it to your project. If you're using Maven, you can include the following dependency in your pom.xml. If you're not using Maven, you can download the Bouncy Castle JR file from the official website and add it to your project's build path. Once you have the library integrated, you're ready to get started with the code. Let's write a simple Java program that demonstrates how to encrypt and decrypt a string using the Serpent algorithm. First, we need to import the required classes from the Bouncy Castle library. Next, we need to set up the main class and method. We will also register the Bouncy Castle provider that supports the Serpent encryption algorithm. Now, let's implement the encryption logic. First, we will generate a secret key for the Serpent algorithm. Here is how to do that. Next, we will need to convert our plaintext message into bytes and set up the cipher for encryption. Here's how you can achieve that. Now the data is encrypted, and we can see the byte array of the encrypted message. Let's print that out in a readable format by converting those bytes into a hexadecimal string. So, we have the encrypted message in the hexadecimal format. Great! Now, for the crucial part, let's implement the decryption of our message using the same secret key. Finally, let's put everything together in a single method to see how our full Serpent encryption and decryption class looks. Great! That's it. You have successfully implemented the Serpent encryption algorithm in Java. Make sure to test it with different plaintext messages and key sizes for practice. Also, remember that while Serpent is a strong algorithm, the security of encrypted data significantly relies on the key management and overall system security. Before we wrap up, let's list some best practices to follow when implementing encryption in your applications. First, always use secure key management practices. Store your keys securely and do not hard-code them in your source files. Next, make sure to use a strong and unique key for every encryption operation, especially when dealing with sensitive data. Additionally, consider using authenticated encryption techniques such as GCM mode where possible, which can help protect against certain types of attacks. Regularly update your encryption libraries and keep an eye on the latest developments in cryptography. Finally, thank you for watching this tutorial. If you found it helpful, please give it a thumbs up and subscribe if you haven't already. Share it with your friends or colleagues who are interested in learning more about Java and cryptography. If you have any questions or topics you'd like to see in future videos, leave a comment below.